All right, everybody. This is Mrs. Crawford. Today we're looking at Unit 1.4, Day 2. So this is the day that we actually start looking at how to prove triangles congruent. So there's a lot of kind of different stuff than what we normally deal with. This isn't just equation, solve it, x equals something. This is going to be a lot more logic, a lot more organization, which is really good. We're training that part of your brain that talks about reasoning and figures out how to have a good argument. But it is going to be very different from what we normally do. So don't feel frustrated if you don't understand it right away. It's going to take a few days to kind of get used to it and to remember the different reasons that we'll talk about for how you prove things. First of all, though, make sure you know that congruent means equal, exactly the same shape, exactly the same size. So we are trying to prove that two triangles are exactly congruent to each other, exactly equal in all ways. So all the angles, all the sides have to be the same. So this first example, just kind of getting in the mindset of picking out those angles and picking out the sides. So we've got a couple things labeled here, and we've noticed that a lot of you guys are in the habit of marking things that are not necessarily true. So we want to talk about being cautious with that here. If this truly is congruent, what type of transformation would this be? Well, it's just slid over across to the next one, so it would be a translation. We don't know for sure whether it is or not, because we don't know if everything's congruent yet, but hopefully it is, and then it would be a translation. So if we look, first of all, check out your angles. These little arches here mean that the angles are congruent. So far we know that angle B is congruent to angle F. Now notice, is there anything else marked in any other angle? No. So please don't put a mark in there. You don't know that they're congruent, so don't assume. So what else do we need to prove? We would have to prove that angle A is congruent to angle E, and that angle C is congruent to angle G. Again, you don't know that yet. You can't just assume and say, well, it looks like it's the same. You have to actually prove it using real facts or the picture and what they give you. Take a look at our sides. These little tick marks here mean that AB is congruent to EF. And these double tick marks mean the same thing about that set of sides. So BC is congruent to FG. So they give us two of the three sides. We don't know anything about this third side yet because, again, nothing's marked. I don't care if it looks the same. I don't care if you think that they're congruent. That doesn't matter. Think about like a persuasive essay in English class. You can't just say, well, I think this is true or I think this is false. You have to have some data. You have to have some resources. You can't just say that it's true because you think so. It's going to be the same practice here. You really have to have actual facts or reasons before you state that two things are congruent. So again, AC and EG would be our last set of sides that are not congruent. We don't know yet. Couple properties to be aware of. Reflexive property, put a big star by that one. You're going to use that almost every proof. We use it very, very frequently. Reflexive, kind of think of the word reflection. So if I have two triangles that overlap like this, and we'll just throw some letters on there, A, B, C, D. So in those two triangles, I've got one triangle on the left, second one on the right. What's the only piece where they overlap? Right in the middle, BD is congruent in the first triangle to BD on the second triangle because it overlaps. Think about your desks in class. If your desks are right next to each other, their edge overlaps, which means it has to be equal. Otherwise, it wouldn't match up perfectly. So reflexive means a piece of the two shapes that overlaps and has to be equal to each other. That's why it says triangle ABC is congruent to triangle ABC. It's the same piece repeated. Symmetric property and transitive property, we're not really going to use those very much, so just kind of be aware of what they mean, but you don't have to know them as much as reflexive. Symmetric, kind of think of the fact that x equals 3 is the same thing as 3 equals x. If it's got an equal sign, you can just flip what's on either side. Transitive property, go ahead and read through that yourself. If you understand what it means, awesome. If you don't, we're probably not going to use it, so it's not a big deal. Okay, so let's go to the next one. All right, so actually doing our proof now. Very first thing you always start with is the given. That's the information that they tell you is true already that you don't have to figure out yourself, which is kind of awesome. You do need to make sure that it's in the picture though, because a lot of times it won't actually label it. So let's check. It says DE is congruent to GE. Well, DE has a tick mark here. GE has a tick mark here. So those are already marked. That's done. DF and GF. Well, DF is here. That's got 2 tick marks. GF is here. That's got 2 tick marks. So that one's done. Angle D is congruent to angle G. Those have some arches going on there. So those are already marked for us. Be careful with this one with the 3 letters. The letter in the middle tells you where the vertex of that angle should be, or where the middle of it should be. So DFE, that's this angle right here. GFE, that's that angle right here. So actually they were really nice, and they marked everything in the picture for you. So now if you scroll down to our 2-column proof, that's what we call this kind of table here. In the statement, we've got all of these things marked as congruent. You always start with stating your reason as given. That's always your first step. Should be an easy point to get to. So now you got to figure out what the heck is not in the picture. Remember, you need to prove all 3 angles and all 3 sides. So let's kind of assess what we have so far. They gave us 1 pair of sides, 2 pairs of sides. So 2 pairs of sides are already taken care of for us. And that means that we still need to prove 1 pair of sides because there's 3 pairs of sides in triangles. So write that off to the side. You're going to have to prove 1 pair of sides. If you look at the picture as well, they also have 2 sets of angles already done for you. These ones in blue and then these ones in black. So 2 pairs of angles are done, which means you only have to figure out 1 pair of angles. Now, if we can't figure out another pair of sides or another pair of angles, it means the triangles aren't congruent. There's not enough information. Again, we can't just look at the picture and say, well, it looks like they're the same. You got to have some information to back it up. So let's take a look at the sides. If we go back up to our picture, we've got DE and DF. What's the only side in that triangle, that number 1 triangle on the left, that has not been named? Well, EF right here in the middle. So I'm going to keep that in the back of my mind. Let's look at the second triangle. It's got EG and GF marked. And again, this EF right down the middle hasn't been marked yet. Okay, well in those 2 triangles, that's the side that overlaps. So they have to be equal to each other. It's literally in the exact same spot, the exact same length. So what is the reason why EF is congruent to EF? If you're not sure, look back at the table at the top of your paper. Which one of those properties talked about things that overlap and are the exact same piece of both shapes? That would be the reflexive property. So that's your reason that goes in there. So we just proved that last pair of sides that we didn't have. So now all 3 sides of both triangles are done. They've been proven congruent. Awesome. Done. We can check that off. We still have 1 pair of angles that has to be proven, though. They've already given us 2, okay, which is great. We still need to figure out that 3rd one. So let's figure out what the remaining angle actually is. In triangle number 1, we've got the blue angle and this black angle here. So we're missing this red one. Remember, when you name the angle, the letter at the vertex should be in the middle. So E, that's my vertex of this angle, so I can name it DEF or FED, either one of those. So I'm going to call it angle. My screen would stay where it's supposed to. Angle DEF. Okay, and then the only other angle in the second triangle that hasn't been named is this spot, kind of right next door to it. And again, E has to be in the middle, so I'll call it GEF. So why are those two things congruent? Okay, we'll think back to the assignment we did the day before this lesson. We talked about third angles theorem. That means that if you know that two angles of a triangle are congruent to two angles of another triangle, automatically the third one has to be congruent. There's nothing you have to solve. There's nothing you have to do with that. It has to do with the fact that all the angles have to make 180 together. So even though I didn't do any math here, because I already know these angles are congruent and these angles are congruent, automatically by third angles theorem, and I'm just going to abbreviate theorem THM because I'm lazy, automatically those have to be congruent to each other. So we just figured out the last pair of angles. So now that I've proved everything, now I can truly say the triangles are congruent. The screen keeps moving on me. There we go. I can truly say this statement right here. Now you don't put prove as a reason. That's not a reason, okay? Prove is what you're trying to prove, but you still have to have some kind of statement here. For today, we're going to put all corresponding parts are congruent. That'll be our reason for everything. So triangle DEF is congruent to triangle GEF. Make sure that you've got the symbols in there, otherwise you're just writing letters that mean nothing. And for this one, they already gave you the little triangles. So that's that proof. We've now proven those triangles congruent. Before we head into the second example, quick refresher. Bisect means to cut in half. If you don't remember, think that bi, that prefix, means to. Sect, think of like dissect in science class. When you're dissecting something, you're cutting it open. So think bisect means to cut in half. It's an easy way to remember that definition. If you split something in half with somebody else, and hopefully you split it equally in half, then those two halves should be equal to each other. So for example, down here, point B bisects AC, which means AB and BC should be congruent to each other. If not, you didn't actually do a good job of cutting it in half. So kind of keep that tucked in your mind. First thing on this problem, remember we talked about you have to start with the given. And they were really nice and already put that statement in there for you. So now we got to figure out what is still missing. Everything's already labeled from the given. So we've got two sides and one angle. So I'm going to have to prove two pairs of angles and one pair of sides still to go. Okay, so let's start with the sides. They tell us something super important here in the given. They say that L bisects or cuts in half KM. Remember we talked about bisecting means to cut into two equal halves. So if I look at KM, that whole length got cut in half, which means KL should be equal to LM. That's my first new statement. KL has to be congruent to LM. The reason is because of the definition of bisect. We talked about bisect means cut in half. If something's being cut in half, it should have two equal pieces. So literally by that definition, it has to be true. Now we've got some angles to deal with here. I know eventually I'm going to be able to prove it by third angles theorem, but I've got to be able to prove one of them on my own first. Something you should always be looking for is vertical angles. We talked about this way back at the beginning of the semester. We called them bow tie angles or kissing angles, or we said they make a V together. And if you look here in the middle, right here where those two arches are, those are vertical angles. So angle JLK is congruent to angle PLM. So angle JLK is congruent to PLM, and the reason is by vertical angles, because that's what the type is. By default, that last one, that angle K and angle M, they're the last two angles of the triangles. They have to be the same by third angle theorem again. Okay, and now I've proven everything, so that means the triangles are congruent. So if I look back at prove, it says triangle JLK and PLM. And again, our reason is all corresponding parts are congruent. Homework is on the back side of this page. Make sure to ask for help if you need it.